Hello students, welcome to the lecture number 2 of the chapter 6. In the lecture number 1, we have discussed about the concepts of straight lines, ray, line segment as well as the concepts of angles. Okay, we had discussed that an angle is formed when the two rays starts from a single point, or if the two ray originates from a single point, then it is known as angle. Okay, how? Here it is a ray OA and this is another ray OB. So here both OA and OB start from a single point. Okay, and that point is known as vertex. Now from this point two rays are being originated and in between them an angle is formed. Okay, it is known as theta. So an angle has two arms and only one vertex. Understood? So in this lecture we will discuss about some other types of angles, okay, like adjacent angle, linear pair angles, supplementary angles, complementary angles, as well as vertical opposite angles. So let us start with the adjacent angles. Okay, so now we will discuss about what are the adjacent angles. So let us first define what are the adjacent means. Okay, adjacent means neighborhood, or one angle lies just next to other, like this. Suppose 2 lies just next to 1, 2 is the successor of 1. Okay, so 1 and 2 are known as neighborhood. Similarly 2 and 3 are known as neighborhood because 2 and 3 just lies nearer to each other. Similarly adjacent means neighborhood angles. Okay, one angle is neighborhood to another angle. How they can be neighborhood? See, two angles are said to be adjacent if it follows three conditions. Okay, what are the conditions? The first condition is that the two angles must have a common vertex. What is it? What is the meaning of common vertex? Okay, see, here is an angle. Okay, suppose the arms are OA and OB, right? And another ray stands here, OC. Okay, then see, here it is an angle, it is also an angle. Suppose let me call it theta 1. Okay, just to identify the types of angle, different angles. Okay, this is theta 2. It means there are two angles. Now see, for this angle, okay, forget about OC, forget about OC, simply consider the angle theta 1. For this angle, what is the vertex? Vertex is O, because this angle has two rays or two arms, okay, and both the arms start from a vertex, a origin, that is known as O. So this angle has vertex O. Similarly, consider this angle theta 2. Then theta 2 has two arms, OB and OC. Now this angle also starts from a common, or starts from a origin or a point that is known as also O. So O is also the vertex for the angle theta 2. Okay, so here it is for angle theta 1 and it is for the angle theta 2. Okay, so both for theta 1 and theta 2 we have a same vertex, we have the common vertex. Okay, so this is the first definition or first condition of adjacent angles. Two angles are said to be adjacent if they have a common vertex. That means one vertex should be common to this angle and that vertex must be common to this angle. Understood? Coming to the second condition. The second condition is they have one common arm. Okay, what is it? See, for the angle theta 1, this is the vertex O. For the angle theta 2, this is the vertex O. Now, for this angle theta 1, let us find out its arms. It has two arms. One is OA. Okay, and what is the other arm? The other arm is OB. So angle theta 1 has two arms, OA and OB. Understood? Similarly, for the angle theta 2, it has also two arms. One is OB and other is OC. Understood? So as you know, each angle has two arms. Theta 1 has two arms OAOB and theta 2 has two arms OB and OC. Now see, it has two arms, it has also two arms. Now compare these two arms. See, there are an arm which is common to both the angle. OB is common to theta 1 and OB is also common to theta 2. Okay, so out of the two arms, one arm is common to both the angle. That is known as one common arm. Understood? So the condition says that two angles are said to be adjacent if they have a common arm. Here the two angles have one common arm, that is OB. Okay, this ray or this arm is common to theta 1 and this ray is also common to theta 2. Understood? So this is known as common arm. Understood? Next condition is the two non-common arms. One arm is common to theta 1 and theta 2. That means except this arm we have another two arms. Yes or no? Yes. And these two arms, they are not common to these two angles. Okay. This arm OA is for theta 1. This arm OC is for theta 2. They are not common, so they are known as non-common arm. Okay, so two non-common arm means OA and OC. They are non-common. The two non-common arm lies on different side of the common arm. That means if OB is the common arm, then the two other non-common arms should lie on opposite side. Okay, one lies towards the right hand side of OB and one lies towards the left hand side of OB. Understood? So the two non-common arms must lie on different side, on opposite side of the common arm. Okay? So you can write here the two non-common arms. Two non-common arms are OA and OC, and common arm is OB. OA and OC lies on two different sides of OB. They should not lie on the same side. See, there is a diagram. Suppose this is OA, OB, OC. Okay, this is an angle theta 1 and it is also an angle. I am talking about the total angle. This is also an angle. Suppose this angle is theta 2. Okay, now for the angle theta 1, okay, consider theta 1. We have two arms OA and OB. Understood? For the angle theta 2, this total angle, we have also two arms OA and OC. Right? Now, for the angle theta 1, we have a vertex, that is O. For the angle theta 2, we have another vertex, that is also O. Now, compare these two conditions. Now, you can see they have a common vertex. That means they follow the first condition. Next, if you compare the arms, then you can see they have a common arm OA. OA is common to both theta 1 and both theta 2. So they also satisfy the second condition. Now can we say these two angles are adjacent? Let us find for the third condition. Here for the angle theta 1, we have two arms OA, OB. Angle theta 2, OA, OC. So OA is the common arm. Okay, so write it. This is the common arm. So the two non-common arms are OB and OC. Now can you say these two angles are adjacent? Yes or no? No. Why? The reason is OB and OC lies on the same side of common arm OA. They should not lie on the opposite side. Okay, they lie only in one side. That is why these two angles are not adjacent angles. In order to be adjacent angle, the two non-common arms should lie on opposite side, on different side. They should not lie on the same side. For this case, this is the common arm. Then OB and OC are not two non-common arms, and they lie on the same side. Okay, that is why they are not adjacent angles. This is the concept of adjacent angles. Okay. So if we add these two angles theta 1 and theta 2, okay, theta 1 plus theta 2, then what do we get? We get the total angle. Okay, when theta 1 is added with theta 2, we will get the total angle. Okay, is equal to total angle. So what is the name of theta 1 angle? Theta 1 is theta 1. So this angle can be represented by AOB. So AOB plus theta 2. This is theta 2. BOC. These two angles are added to give the total angle. Okay. So what is the name of the total angle? This is the total angle. Okay. So for this total angle, the arms are OA and OC. Okay. So you can write this angle as AOC. Understood? So these two angles are combined to give the value of total angle. Okay. So the next type of angle is linear pair angles. Linear pair angles. You can see there are two terms. One is linear, another is pair. What is the meaning of linear? Linear means a line, a straight line, like this. Okay. And pair means two. Okay. So two angles are said to be linear pair if they form a line. This is the simple definition, not the exact definition, but for better understanding, you can remember it. Two angles are said to be linear pair if they form a line. Understood? Let us understand the exact definition of linear pair angles. Okay? So, the exact definition is two adjacent angles are said to be linear pair. So, in order to be linear pair, the two angles must be adjacent. You have to remember it. In order to be linear pair, the two angles must be adjacent. Okay. So the two adjacent angles are said to be linear pair if the two non-common arms form a straight line. Okay. Let us understand it. So as we know, if there are two angles, okay, O, A, B, C. This is the angle theta 1 and this is the another angle theta. Now these two angles are adjacent. Why? Because these two angles have a common vertex as well as they have a common arm. This is the common arm. OB is the common arm. And the two non-common arms are OA and OC. So OA is a non-common arm and OC is also non-common arm. So in this diagram, you can see the two non-common arms lie on different side of the common arm. But here, they will not form a straight line. Okay? They do not form straight line. It goes in this direction, it goes in this direction. Okay? If you extend them, then these two angles cross each other. They do not form a straight line. Okay? But let us consider another example. Okay? Here. Suppose this is a ray, this is an angle OA, OB, right? And here one more angle is, so here there are two angles, okay? One angle is theta 1 and another angle is theta 2. Okay, as like these two are adjacent angles, similarly these two are also adjacent angles. Why? Because for the angle theta 1, for this angle, it has two arms OA and OB. So OA and OB. It has a vertex O. Similarly, for the angle theta 2, it has also two arms. One is OB, other is OC. And it has a vertex O. Right? Now see, if you compare these two angles, then they have a common vertex. Similarly, they have a common arm. OB is the common arm which is common to both theta 1 theta 2. So these two angles satisfy the first two conditions of adjacent angle. Next is the third condition. Whether the two non-common arms lie on opposite side or the different side of the common arm. So here OB is the common arm. Okay. So the two non-common arms are OA and OC. Now you can see these two arms lies on two opposite sides or not? Yes, they lies on two opposite sides, to different sides. Hence, this theta 1 and theta 2 angles are adjacent angles like these two angles. Understood? These are also adjacent angles. These are also adjacent angles. So what is the difference between these two types of angles? Here, the two non-common arms OA and OC, though lie on two different sides, but they do not form a straight line. But here, the two non-common arm OA, this is non-common, and the non-common arm OC will form a straight line. They lie on a single straight line. Yes or no? Yes. The two rays OA and OC lie on a same straight line. Okay. This is the only difference between these two types of angles. Now, this type of angles are known as linear pair angles. Okay. So, from the definition, it is given that two adjacent angles are said to be linear pair if the two non-common arms form a straight line, or if the two non-common arms lie on a straight line. Okay. If they do not lie on a straight line, then they are only known as adjacent angle. But if they lie on a straight line, then these angles are known to be linear pair. Understood? This is the big difference between adjacent angle and linear pair angles. Right? Now, you can write the angle theta 1. Theta 1 means what? AOB. AOB angle. And BOC are linear pair. Linear pair angles. Understood? Next is, as we know, it is a straight line, and we have studied a straight line is known as straight angle. Then what is the value of straight angle? It is 180 degree. It is also a straight line. It means the total angle is 180 degree. Okay, how? See, if you consider a protractor, okay, then you can see this side is 0 degree and this side is 180 degree. So it forms a straight line and the angle formed is 180 degree. Similarly, it is also a straight line. It means the total angle is 180 degree. Okay, so we can write the total angle is 180 degree. Okay, so in case of or in place of total angle, you can write theta 1 plus theta 2 because these two angles are combined to form the total angle. So theta 1 plus theta 2 is equal to 180 degree. Okay, so theta 1 means AOB plus this is BOC theta 2 is equal to 180 degree. So what we get? We get a conclusion that for linear pair angles, the two adjacent angles are combined to form 180 degree or to give 180 degree, or the sum of two adjacent angles for a linear pair angles are 180 degree. Okay, so let us write the sum of two linear pair angles is 180 degree. Okay, I have told you the reason. The reason is that they form a straight line, and the straight line means it will make an angle 180 degree. So this angle plus this angle, theta 1 plus theta 2 is equal to 180 degree. In place of theta 1 we write AOB angle, and in place of theta 2 we write BOC angle. So the two adjacent angles or the two linear pair angles are combined to give 180 degree. Okay, so this is the complete idea about linear pair angles. Okay, so from this concept we get another conclusion. What is the conclusion? The conclusion is that, see, it is a straight line. Yes or no? Yes, it is a straight line. Okay, now on this straight line we draw a ray. Okay, or this ray OB stands on the straight line. Okay, so whenever there is a straight line and another ray stands on it, then two angles are formed, and these two angles are linear pair angles. So ultimately, you can write whenever a straight line is there and another ray stands on it, then the sum of the two angles formed is equal to 180 degree. Okay? So we can write when or whenever a ray, okay, this is a ray OB which stands on a straight line. So whenever a ray stands on a straight line, okay, then the two angles formed, then the sum of two angles, okay, these two angles are adjacent, remember it, these two angles are adjacent, then the sum of two angles formed is equal to 180 degree. Okay, this is known as axiom number 6.1. This is an axiom. Okay, axiom means it is a self-proven statement. We do not need to prove it. Okay, it is a supposition. What is the supposition? If a ray OB stands on a straight line, then the two angles formed, if we add them, then they will give 180 degree. Understood? So this is axiom number 6.1. Similarly, we can write the converse of this statement. Okay, converse means we will start writing from the back, and that is known as axiom 6.2. What is axiom 6.2 tells you? It tells you if the sum of two adjacent angles, okay, if the sum of two adjacent angles, see, these two angles are adjacent angles, okay, if their sum, suppose this is theta 1, this is theta 2, if the sum of two adjacent angles is 180 degree, then these two angles are known as linear pair angles. Okay, it is also true or not? Yes, it is also true. We know that if two adjacent angles are added to give 180 degree, then no doubt they are known as linear pair angle, or they will form a straight line. Okay, so this is the axiom number 6.2. So you can write if the sum of two adjacent angle is 180 degree, okay, then two angles are known as linear pair angles. Then two angles are linear pair and they will form a straight line, and the two non-common arms form a straight line. Okay, so this is the axiom number 6.2. It tells you that if the sum of two adjacent angles is equal to 180 degree, then two angles are known as linear pair angles and the two non-common arms form a straight line. Okay, so the axiom number 6.2 is just opposite of the axiom 6.1. Okay, that is why axiom 6.2 is known as converse axiom 6.1. Converse means just opposite. Okay, so this is the basic concept of linear pair angles. Let us take some examples of linear pair angles. Okay, suppose this is a straight line. Okay, A, B, and on this straight line another ray lies. Suppose the name of the ray is OC. Then how many angles are formed here? Two angles. This is and this is, suppose this is theta 1 and this is theta 2. Whether the two angles are adjacent or not? Yes, they are adjacent, because for the angle theta 1 this is the vertex O, for the angle theta 2 this is also the vertex O. So O is the common vertex to both the angles. Similarly, for the theta 1 angle, OB and OC are the two arms, and for the theta 2, OC and OA are the two arms. So OC is the common arm, and here the two non-common arms are OA and OB, and OA and OB form a straight line. Yes, they form a straight line. Hence, for these two types of angle, you can write theta 1 plus theta 2 is equal to 180 degrees. Okay, so ultimately you know that if a straight line is there and another ray lies on it, then the two adjacent angles are formed is equal to 180 degree. Okay. Next is, suppose there is a straight line, okay, PQ, and on this straight line two rays are there, two rays. Suppose this is a ray OM and another ray ON. Then how many angles are formed here? It has three angles. Here one angle, here one angle, here one angle. Suppose this angle is theta 1 having vertex O and arms OQOM. This is the angle theta 2 having vertex MO and the two arms are OM, ON. Here the angle is theta 3 and the arms are ON and OP. So here three angles are formed. That is why these three angles are not known as linear pair, because pair means two angles. Since there are three angles, so they are not linear pair angles. Okay, we draw it only to calculate the sum of the three angles. What is the value of the sum of the three angles, theta 1, theta 2 and theta 3? We have to find it. Okay, as we know, this is a straight line, and we know a straight line means a straight angle. Straight angle is equal to 180 degree. So the total angle is 180 degree. So total angle means what? Theta 1 plus theta 2 plus theta 3. So here all the three angles are combined to form 180 degree. Right? Similarly, if you draw a straight line PQ, and on the straight line if we draw infinite number of rays, okay, having a common vertex. Suppose this is A, B, C, D, E. So here we have 1, 2, 3, 4, 5, 6. Okay, theta 1, theta 2, theta 3, theta 4, theta 5 and theta 6. So here if we add all the angles, then what is the value? It is also 180 degree. The reason is that they all form a straight angle. It is a straight line. The total angle is equal to 180 degree. Hence, the sum of all the angles formed on this straight line is equal to 180 degree. So here we get a conclusion that if infinite number of rays lie on a straight line, then the sum of all the angles is equal to 180 degree. Okay, you can note it down. If infinite number of rays lie on a straight line, then sum of all the angles is always 180 degree. Understand? And now we will discuss about another two types of angles, that is complementary angles and supplementary angles. So let us first discuss about complementary angles. What are the complementary angles? Two angles are said to be complementary if their sum is 90 degree. Okay, you can take any two angles, whether the two angles may be adjacent or they may not be adjacent. That doesn't matter, but their sum must give 90 degree. Okay, for example, if this is an angle whose value is 30 degree, okay, and there is another angle, this is an angle. So suppose this angle's value is 60 degree. So here these two angles are adjacent angles because they have a common vertex and they have a common arm, and the two non-common arm are on the opposite side or are on the different side of the common arm. But the sum of the two angles is how much? 90 degree. That is why these two types of these two angles are known as complementary angles. Right? Let us take one more example. Suppose it is a straight line and there are how many angles? Three angles. out of the three angles, suppose this angle's value is 40 degree. Okay, O, A, B, C, D, and this angle's value is 50 degree. Okay, and what is the value of this angle? Since total angle is 180 degree, this is 50, this is 40, there is total 90. Now this must be 90. Forget about this. Now out of these three angles, this angle AOB and this angle COD is, when added, then they will give 90 degree. Okay, so you can write AOB plus COD is equal to 40 degree plus 50 degree is equal to 90. So here this angles and this angles are not adjacent. Okay, why they are not adjacent? Because though they have a common vertex, but for this angle the arms are OA and OB, for this angle the arms are OD and OC. They do not have any common arm, so they are not adjacent. Still, their sum gives 90 degree. That is why these two angles are also known as complementary angles. Here also these two angles are also known as complementary angles. So in order to be complementary angles, the sum of the two angles value must be 90. But it doesn't matter whether they are adjacent or they are not adjacent. Understood? Let us take an example of two complementary angles. Suppose these are two angles, two adjacent angles. Suppose this angle is x degree. Okay, A, O, B, C. Now it is given in the question that BOC angle and COA angle are complementary. It is given. We have that condition. Complementary means what? Complementary means this angle plus this angle is equal to how much? Is equal to 90 degree. Suppose you can take this angle to be theta. Okay, so you can write theta plus x degree is equal to 90 degree. Reason is the two angles are complementary. So we have to find out this angle's value, right? So here theta is equal to how much? 90 degree. When x goes to the right hand side, it will be minus x. Okay, so we get a conclusion that if out of the two complementary angles, one angle is x degree, then the other angle must be 90 minus x degree. Okay, how? Suppose one angle is 40 degree. And what is the other angle? Other angle is 90 minus 40, there is 50 degree. Yes or no? In place of 40, you can write x. So it will be 90 minus x. So out of the two complementary angle, if one angle is x degree, then the other angle must be 90 minus x degree. Okay. So this is all about the complementary angles. Let us talk about the another angle, that is supplementary angles. As like the complementary angles, supplementary angles means if the sum of any two angles is equal to 180 degree, then they are known as supplementary angles. Okay, here also you can take adjacent angles or the two angles may not be adjacent, that doesn't matter, but important thing is the sum of the two angles must be 180 degree. Okay, see, if there are two angles, okay, and these two angles are adjacent. Why they are adjacent? Because they have a common vertex and a common arm. As well as these two angles are also linear pair. Why? Because the two non-common arm form a straight line. So the total angle's value is 180 degree. Okay, this angle, suppose theta 1, and this angle theta 2 is equal to how much? 180 degree. So here the two linear pair angles are combined to form 180 degree. So these two angles are also known as supplementary angles. Okay. Another example. Suppose there are how many angles? 1, 2, 3. Here also an angle formed 4. Suppose theta 1, theta 2, theta 3, and theta 4. If the theta 1's value is 60 degree, right, and theta 3 value is 120 degree, then whether theta 1 and theta 3 are adjacent or not? No, they are not adjacent because they do not have any common arm. Okay, but their sum gives 180 degree. So the angle theta 1 and theta 3 are known as supplementary angles. Here also the two angles are also known as supplementary angles. So it doesn't matter whether the two angles are adjacent or not. But most important thing is that the sum of the two angles must be 180 degree. So you can say yes, the two linear pair angles are always supplementary. Why they are supplementary? Because sum of the two angles formed in a linear pair angles is equal to always 180 degree. Okay, so you can write note two linear pair angles are also supplementary, as I have told you the result, because always their sum is 180 degree, so we also termed as supplementary angles. Okay, next thing is, if out of the two supplementary angle, if one angle is x degree, then what is the value of other angle? We have to find it. Okay, for example, if one angle is 60 degree, then what is the value of other supplementary angles? How can we find them? 180 degree minus 60 degree, that is 120 degree. So 60 degree and 120 degree are added to give 180 degree. So these two angles are supplementary. So if one angle is x degree, then what is the value of other angle? Other angle must be 180 degree minus x, like this. Okay, so note it down. If one angle out of two supplementary angle is x degree, then the other angle must be 180 degree minus x. Understood?